Hey y'all, today we're going to be talking about graphing a system of inequalities. So a system of inequalities, just like a system of equations, is going to involve graphing two inequalities on the same graph. And while just graphing lines isn't going to be too hard, it can be a little confusing to talk about the shading. Okay, so to solve a system of inequalities, you do the exact same as you do for graphing inequalities. We're going to graph the line and we're going to shade the corresponding area for each line. Your answer is the double shaded area. And we're going to see what I mean by this in just a second. So instead of a point, like we do for a system of equations, our answer is a set of numbers. So instead of just a single point like we get with a system of equations where the two lines cross, we get all of the points that could fall into the shaded region. So let's look at example one. We're going to start by graphing each of these inequalities separately, and then we're going to graph them both on the same graph. So 1/2 x plus 1, our slope is 1/2, and our b is 1. So here on our graph, y-intercept at exactly 1, slope of rise over run, so 1/2, so up 1 to the right by 2, and we'll just keep following that from there. And then to the left, sorry, just in case you can't see that. Same thing, just opposite direction. And then is a less than sign, so that's going to be shade under and dotted line. So dotted line for my graph, and then less than means shade under. And there we go. Hey, so that's the first one. Second one, we have y is greater than or equal to -4x minus 2. So I'm going to do this one in, we'll do red. So slope is -4 over 1. And our y-intercept is -2 down there at the end. Okay, so from here, y-intercept first, so -2. Then we are rising by -4, so that means we're going to go down by -4. So down 4, 1, 2, 3, 4, and to the right by 1. Same thing in the opposite direction. And I'll put that first point if you can't quite see it. Then this is greater than or equals to, so this is actually going to be a line because of the equals to. And then greater than means I am going to be shading above. All right, so this one should be, these two should be pretty familiar, graphing those individually. We practiced it last class. Now we're going to graph the system of inequalities by graphing both of these on the same graph. So we're going to start by graphing y equals 1/2 x plus 1. So plus 1, 1/2. Still a dotted line. And still shading below. And then my second equation, y equals -4x minus 2. So y-intercept of -2. Oop, wrong thing. Y-intercept of -2. Slope of -4/1, so down 4. To the right by 1. And same thing in the opposite direction. And of course, this one was a solid line. And it is greater than or equal to, so we did shade above. So what you should hopefully notice is that we get this whole area where our red and purple cross, and that is our solution set. So what area on the graph, if I was to give these areas numbers, so we'll say 1, 2, 3, and 4, which area will we say is the area on the graph that is part of the solution set? That would be section 3. Okay, it's where the red and the purple, the two shaded areas, cross. So then is the point 1, 4 in the solution set. So we'd go to 1, 1 in the x, 4 up in the y, 1, 2, 3, 4. So that'd be this point up here. So while that point is in the shaded region for our second equation, y is greater than or equal to -4x minus 2, it is not in the shaded region for our first equation. So since it doesn't fall in that set 3 where both of the shaded areas cross, it is not a part of the solution set. So that is a system of inequalities, y'all, and it is kind of a task to get all of them graphed and shaded. So you don't see these a ton, but really still the important skill is making sure you can at least graph one inequality. And this is kind of the advanced skill, being able to graph the two inequalities and then pick out the shaded region. But I do love it, especially now that we have this technology. It can be really easy to see where that shaded area is because it makes it really clear. Okay, so let's do another one to practice. So number 2, we have y is less than 2x minus 1 and y is greater than -x plus 2. So we'll start with our first one. Y is less than 2x minus 1, so m is equal to 2 over 1. B is equal to -1. So -1 right here on the graph, 2 over 1, so we're going up 2 and to the right by 1. And same thing in the other direction. And then it is less than, so it's going to be dotted. Oh, those lines are super off. Obviously, you don't have to be perfect, but you should be pretty decent. Okay, and then it is less than, so we're going to shade below our graph. All right, second equation, y is greater than -x plus 2. So m is actually equal to -1 because that's the number we don't write sometimes. B is equal to 2. So on here, y-intercept at 2. Okay, slope of -1 over 1. So we're going to go down to the 1 to the right by 1. And same thing in the other direction. And then still just a greater than sign, so it's still going to be dotted. Which, of course, when we have that many dots, it's almost like we don't need to be dotted. And then greater than, so we are going to shade above the graph. Perfect. Okay, so is the point 3 comma negative 2 in the solution set? So we're going to go to 3 comma negative 2. So 3, 1, 2, 3, negative 2, 1, 2. It's close, but it looks like it is just outside our solution set. So this would once again be no for our point being in our solution set. Okay, let's do one more. So we have y minus 3x is less than or equal to 2, and we have negative y plus x is greater than negative 5. So this one, both of these are not solved for y yet. So we're going to have to solve them for y before we can graph them. So on our first one, I need to add that 3x over to the other side. So I get y, wrong drawing tool. We get y is less than or equal to positive 3x plus 2, because I just added that 3x over to the other side. This one, I need to subtract x over to the other side first. So negative y is greater than negative x minus 5. Then I need to divide everything by negative 1. And remember, when we divide by a negative, not only do we switch the signs of all the numbers, we also switch the sign of our inequality. So this becomes y is less than x plus 5. Okay, so now we have our two graphs, 3x plus 2 and x plus 5. So for 3x plus 2, m is equal to 3 over 1, b is equal to 2. So on our graph, y-intercept of 2, slope of 3 over 1. So up 3, 1, 2, 3, to the right by 1 for each of our points. Same thing in the other direction. And then it is less than or equals to, so it is going to be that solid line. And less than, so we're shading below. Then for our second graph, x plus 5, m is 1, because that's the number we don't always write in front of our x. B is just 5. So for our y-intercept, it's up at positive 5. 1, 2, 3, 4, 5. Y-intercept is at 1, so up 1 to the right by 1. And then it is less than, so it is going to stay dotted. And then less than, so we are shading down below. So because of that dividing by negative, both of our inequalities actually ended up being less than. And because our slopes are so close to each other, we end up with this huge swath of overlapping shaded area on our graph. And just that little tiny piece of just purple. Okay, so let's answer the question, is 2 comma 3 in the solution set? Well, let's go plot 2 comma 3. So 1, 2 comma 3. Okay, that one looks pretty clearly in the solution set, and our answer would be yes. So that is graphing a system of inequalities, y'all. So the big thing to keep in mind is just like graphing a single inequality, okay, you're just graphing both of them on the same graph. And then, of course, that follow-up statement of, if I picked a point out, could you tell me that it is in the solution set or that it isn't in the solution set? And that's really where the questions are going to come with your systems of inequalities, is either telling me, like, if I labeled the regions, which region is the solution set? So like on number 1 where we said 3, or if I gave you a point, being able to tell me if the point is in or not in the solution set. But that is system of inequalities.